Okay, so number 29 says the height of a ball t seconds after it is thrown upward from a height of 32 feet with an initial velocity of 48 feet per second is, it gives us an equation, f of t equals negative 16t squared plus 48t plus 32. Okay, so that's our equation. And A says verify that f of 1 equals f of 2, okay? So, we know that this is continuous and differentiable because it's a polynomial. And so, to find f of 1, we'll just plug in 1 into the equation. That's 1. Okay, and so you get negative 16 plus 48 plus 32. And that turns out to be 64. So I know that f of 1 is 64. Now, let's go ahead and find f of 2. So we'll just plug in 2. So negative 16 times 2 squared plus 48 times 2 plus 32. So this will turn into negative 64 plus 96 plus 32, which turns into 64. So we know that f of 1 equals 64, which equals f of 2. So f of 1 and f of 2 are equal. And so we've done A. We've proven that. And then B says that according to Rolle's theorem, what must be the velocity at some time in the interval 1, 2? And that tells us to find that time. So that's our interval, and we have to find out what Rolle says. Okay, and so Rolle says that because f of t is continuous, on the closed interval 1, 2, and differentiable. I'm going to go a long way so you can see this. And differentiable on the open interval 1, 2, then there must exist a point where f prime of c equals 0. So that's what Rolle's theorem says. Okay. So when we do this, we need to find the derivative. So f prime of t equals, that would be 16 times 2, negative 32t plus 48. That's our derivative, okay? So now we'll set that equal to 0. Let's see, we can factor out negative 16. So that'd be 2t minus 3. Yeah? Okay. And so the 16, if you divide by 16 is 0. So 0 equals 2t minus 3. So 3 equals 2t. So we know that t equals 3 half seconds. And this is part B. Okay? So there's my work. And so here's the whole problem. And we have proven 29.